Hello. So I'm starting this session. This is the second lab session. In the last lab, we had generated sinusoidal wave using MATLAB. You can see the code available here. What we did is that we had simply taken this fs or sampling frequency as 1000, and in this after that we discrete generated the discrete time. Then we generated the sinusoidal wave with the command cos 2 into pi into frequency we had taken as 10 hertz into n, and then we generated the second sine wave with s1 equal to sine 2 into pi into, so these are two sinusoids which are both of 10 hertz with sampling frequency of 1000. So if you see the wave, once we get the wave we will be seeing so the output will be as this one. Now if I maximize it, you can see the wave are same frequency as they are 10 hertz. Now as they are 10 hertz, what happens, you see the peak, two peaks are having a distance of zero point 0.1, and if you take the reverse of zero point 0.1 it's 10 hertz. Here you can see it clearly in this particular cos wave. This starting point is 1, next peak is at zero point 0.1. Okay, so if I, instead of doing this plot, if I use a command stem, you get the discrete plot, STEM, and here also I replace it as STEM and run it again. So the screen has come. So you see, this is the discrete time plot. The time is sampled at 1 by 1000. So as it is 1 by 1000, so for one wave you are having the range 1000 by 10, so it will be 100 samples. If you want to see in a much clearer way, what I do, I minimize this and change this particular time period which we are plotting, where we are plotting the whole sequence of 1000 points. Let me plot only 1 to 100. Here also 1 to 100. As it is matrix, the sizes have to match. The same thing will repeat here, 1 to 100, and here also 1 to 100. I run it. So you see, this is the wave. So in this wave, what we are having, the first one is the cosine wave and the second one is sine wave. So in both we have one cycle. Here we have a first cycle, then the second half cycle, and this is, so it is a quarter positive cycle, full half cycle, and the next quarter positive cycle, and here you have the positive cycle and the negative cycle. So this is the cosine wave and sine wave. There has been a mistake. The first one should be cosine and this will be sine. I've just written it vice versa. So this is the cosine wave, this is the sine wave. The labeling was wrong, anyway I have changed it. So you can see both are of 10 hertz. Now what we can do, here we know 10 hertz because this, how many samples you see, out of this 1000 samples we have 100 here. Now let's change it. Say I make it 100, and this also I make it 100. So now there should be 10 samples. Okay, so when you are having 100 hertz, the wave here you are having how many cycles? 1, 2, 3, 4, 5, 6, and 8, 9, 10. So we have 10 cycles here and 10 cycles here, which is making uh, the same 1000 points. So 100 points. So in 100 points in 100 hertz, you are having in 10 cycles, because 100 is to 1000. So what we are actually having here is, if you see carefully, let me bring in the annotation. So we have one cycle here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 cycles. Similarly here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in both cases we are having 10 cycles. Now let me get back to the old one, 10 and 10. Run it. You are having only one cycle. And now let's make it 20. 20, 20. Run it. You are having 1, 2, 2 cycles. So for 10 hertz 1 cycle, for 20 hertz 2 cycles, for 30, 40, as you go on to 100 you have 10 cycles. Now this 10 cycles is in 1000 points, whereas your sampling frequency is how much? 1000. Okay, so when you have sampling frequency of 1000, in 1 second you are having 1000 samples. So based on that, this is the condition. Now if we don't use this, and we have different ratios, so what we can do here is that we can make, say, different waveforms. Say let me remove this title, label and so on, and remove these also, and let me generate sine waves only. So we have S1 as for say 10 hertz, then we do the same thing, S2 for 20 hertz, then S3 say 50 hertz, and S4 which is say 100 hertz. The sampling is 1000. As we have 4 graphs, let me put here 411, 412. Say this is S1, this is S2, and I copy these two and paste it here, 413 and 414, and similarly the signals will be S3 and S4. I rename it as file save as. Let me name a new file. Okay, try F. So I run it. So what do we get here? You can see here, 1 cycle, 2 cycle, 5 cycles, 10 cycles. So this is for 1000 sampling frequency and taking only 1000 values. Now just let's do some tuning, make it 2000. Now if I make 2000 in 100 values, I'll have half the range. So as it is 2000, half the range, because so it's we have half cycle, one full cycle, 2.5 cycle, and 5 cycles. So as we increase the sampling frequency, here the cycle, the samples will so when we have 5000, you have this one having two waves, okay, in 1000 samples. Till now what we have been doing, we have taking only 100 samples to see the whole thing carefully. But what you can see here is that this is totally based on the ratios, and there is a particular ratio between what is the sampling frequency and what is the frequency that is being used. So what we have here is that this is, if I put a percentage, 10 by fs. So similarly, this is 20 by fs, this is 30 by fs, and this is for 100 by fs. So 10, 20, 50 by fs. So this is the ratio, or you can say vice. So we are taking the ratios based on this, and based on this we are having the signals. So this is how the signals behave. But we can make another set of things. The ratio, if you want to see, the ratio of 2000 is to 20, and the ratio of 10 is to uh, 2001. Say if we take 10 to 1000 and 20 to 2000 or 50 to 1000, then they'll be same. So let me consider another signal. Say I save it as ratios. So here we have fs1 equal to 1000, n1, this s1 is using n1, and this 10. So 10 is to 1000 equal to 20 is to 2000. So to show that, let's take this signal and again paste it here, but here I'll make it fs2. This is 2000, this is n2. Obviously if this is fs1, then this will be fs1, sorry, fs2, fs1, fs2. So what we have done here, fs1 equal to 1000, fs2 equal to 2000, n1 equal to 0, 1 by fs1 to 1 minus 1 by fs1, n2 is equal to 0, 1 by fs2, 1 minus 1 by fs2, s2 equal to same thing with n2. So to show these ratios, we need subplot 211 and 212, s1, s2, n1, n2. I don't need this. Let's see the difference. Just a minute, let me check. Oh, here I forgot to make it 20. See, both the waveforms are same. Difference is that in one is 1 by 10 by 1000, another is 20 by 1000. So here everything works out based on the ratio. The ratio between 10 Hertz and 1000 as sampling frequency is same as 20 Hertz with respect to 2 kilohertz. So here it is 1 kilohertz, 1 kilohertz, and here it is 2 kilohertz. Here it is 10 Hertz, and here it is 20 Hertz. But the waveforms look same. Now in case I change that to 2000 to 5000 and make it 50, you get the same thing. So the ratio is the thing that is very important and nothing else.